Lesson 2, Identities-Addition Theorems. Now in this theory I'm going to prove addition and subtraction theorems, but I've just, for simplicity, I've just called them all addition theorems. And we're going to prove these 6 results, starting with the cos of A minus B equals cos A cos B plus sine A sine B, and going through the rest of those. These are important theorems and you should commit these to memory, and I would advise deriving them because the proofs are quite long. Well, the first one is particularly longer than the others. Okay, let's have a look at them. So we'll set up the diagram here. I've got a unit circle, okay, and this is, we'll call this one here C. Yep, that's C there. Alright, now, if we look at this triangle here, we can see from the cosine rule that, first of all, to get these coordinates, B is cos theta sine theta, because that's the angle theta, and that's 1. So that will be x on 1 is going to be cos theta, so x is cos theta, and y on 1 is sine theta, and so on the other side as well. Now, what we'll do is we'll write this down as AB squared is equal to, now that will be 1 squared this side plus 1 squared minus 2 times 1 times 1 cos of the angle between, and the angle between is the cos of phi minus theta. Okay, so that becomes simply 2 minus 2 cos phi minus theta. Now, using the distance formula, you can see that AB squared is equal to the cos of theta minus the cos of phi all squared plus the sine of theta minus the sine of phi all squared. Now, removing those brackets, we get, now I'll do it this way, cos squared theta minus 2 cos theta cos phi plus cos squared phi, and underneath I'll write sine squared theta minus 2 sine theta sine phi plus sine squared phi. You can see that, let's colour this in a bit, take this one here and this one here, you can see they're both equal to 1. So we can write this down as being 2, 1 plus 1, 2, minus, we'll take the 2 out as a common factor, and that will be cos theta cos phi plus sine theta sine phi. And that's equal to the top bit there, isn't it? Right? That must equal that. I think you can see that, therefore, just looking at those, equating those two, cancelling the 2's and dividing through by negative 2, we get the result that the cos of phi minus theta is equal to cos of theta, the cos of phi, plus the sine of theta, the sine of phi. So that gets the first one out of the way. It's the first result. Right, now to get the next one, we're going to let theta equals minus phi. Sorry, minus theta. Now, we can see then that the cos of theta, now putting the minus then becomes plus theta equals, now this becomes the cos of minus theta cos phi plus the sine of minus theta, the sine of phi. Now the cos of minus theta is just cos theta, because we're in the fourth quadrant, so it becomes the cos of theta cos of phi, and this one is going to be, of course, the sine of minus theta is minus sine theta, so that's minus the sine of the theta sine of phi. And that gets the next one out of the way. That's this one. Okay, moving on. Now, we know that the cos of 90 degrees minus theta plus phi is equal to the sine of theta plus phi, because they're complementary ratios. And rearranging this, we'll say the cos of 90 minus theta minus phi, using the difference one, is going to be, put it down here, the cos of 90 minus theta cos phi plus the sine of 90 minus theta sine phi. Okay, and that is equal, now the cos of 90 minus theta is the sine of theta, so it's the sine of theta cos of phi plus the cos of theta the sine of phi. Okay, let's pause that video for a bit. Okay, now in a similar way, what we're going to do is we'll let theta equal phi again. So let theta equals minus theta, and so by replacing that, I'll write this out again. The sine of, we notice the sine of theta plus phi is equal to the sine of theta cos of phi plus the cos of theta sine of phi. So we're going to write that as, this is going to be the other way around, so it's the sine of phi minus theta is equal to, now this becomes, putting the minus theta in there, the sine of minus theta cos of phi plus the cos of minus theta the sine of phi. And let's take this around the other way, so we get now that that becomes the cos of theta sine of phi minus the sine of theta the cos of phi. Alright, so we're almost done. We just got the last, the tan one to do. Now the tan of theta plus phi is equal to the sine of theta plus phi over the cos of theta plus phi, which equals the sine of theta cos phi plus the cos of theta sine phi all over the cos of theta cos phi minus the sine of theta sine of phi. What we'll do, we'll divide the numerator and denominator by cos theta cos phi. Right? So doing that, we'll get here the sine of theta, the cos of phi, over the cos of theta cos phi minus the cos of theta sine phi over the cos of theta cos phi all over the cos of theta cos phi over the cos of theta cos phi minus the sine of theta sine phi over the cos of theta cos phi. Now we'll have a bit of fun doing a bit of cancelling here. Okay, now you notice these guys go out. And over here these guys go out. And down here this is just all goes out, and you just get 1. And here nothing goes out. So we write that down now as equal to the sine of theta and the cos of theta is the tan of theta, and the sine of phi and cos of phi is the tan of phi. There should be a plus up there. Tan of phi all over, now this is just 1 minus, now this is tan theta, tan phi. Okay, and the final one. Right, I'll leave a bit of room. So again, we're going to let theta equals minus theta. So we get the tan of, that is phi minus theta, is equal to tan of minus theta plus tan of phi over 1 minus the tan of minus theta, tan of phi. Tan of minus theta is minus tan theta, so this is going to be the tan of phi minus the tan of theta all over 1. Now this becomes minus, that becomes plus, plus the tan of theta, tan of phi, and that's the 6 results which you need to commit to memory. Right, now here's an example. Example 1, given that sine A plus B equals sine A cos B plus cos A sine B, show that the sine of 75 degrees equals root 6 plus root 2 on 4. Now what we'll do, we'll let A be equal to 45 degrees and B equal 30 degrees. Of course, we can see that the sine of 75 degrees will be equal to the sine of 45 degrees plus 30 degrees. So that will be equal to the sine of 45 cos 30 plus the cos of 45 times the sine of 30. From your exact values, recall that the sine of 45 is 1 over root 2. Coming from that little diagram, we've got a 1 at 1, 45, Pythagoras root 2. So the sine of 45 is 1 root 2. And the cos of 30 is root 3 over 2. Again, that comes from this little diagram. Okay, you've got your 2, there's your 1 there, which is 60 degrees. There's your root 3. So you can see the cos of 30 is equal to, 30 is up here, root 3 on 2, plus cos of 45 again is 1 root 2, and the sine of 30 is going to be a half. Right, I'll tidy it up a little bit. This would be root 3 plus 1 over 2 root 2. Now rationalising, get root 2 over root 2. Of course that becomes root 6 plus root 2 all over root 2 by root 2 is 2 times 2 is 4. Right, now in example 2 we have to prove that tan A minus tan B over tan A plus tan B is equal to sine A minus B over sine A plus B. Now we'll start with the left hand side. Left hand side equals a tan A minus the tan of B over the tan of A plus tan of B. Because we've got sines, I'll change this to sine over cos. So it becomes sine of A over the cos of A minus the sine of B over the cos of B divided by, and this will be sine of A over the cos of A plus the sine of B over the cos of B. Okay, now this becomes a common denominator of cos A cos B, that is sine A cos B minus cos A sine B all over cos A cos B divided by, this becomes sine of A cos of B plus the cos of A sine of B all over the cos of A cos of B. And of course the sine of this one here is just the sine of A minus B over the cos of A cos of B. We'll turn this upside down. It becomes the cos of A cos of B over the sine of A plus B. These go out and you get the result, the sine of A minus B over the sine of A plus B, which equals the right hand side.